Assalamu alaikum. This is second degree theory lecture series. So today here is a theorem. Functor preserve isomorphisms. Okay. Here is a theorem, a proposition we can say. Functor preserve isomorphism. So how can we prove the statement functor preserve isomorphism? First of all, let's define the definition of isomorphism. F is a morphism from X to Y in category C. There exists a morphism G from Y object to X in category C such that G of F is equal to ID on X and F of G is equal to ID on Y. Okay, means there is a morphism F from X to Y and G from Y to X. If we compose first of all F, then G. So should be equal to ID on X, means the morphism from X to X. If we first go from Y to X, G, then F means F of G. So this should be equal to ID on Y. This is the morphism from Y to Y. Okay. So we have to prove functor preserve isomorphism. Let's say the functor f send x to f of x and send y to fy in category D. Send f to f of f from fx to fy and send g from fy to ff according to the definition of functor. So f of g is equal to, according to the definition of isomorphism, f is an isomorphism, so this should be equal. Okay, these two conditions should be hold, means g of f is equal to id on x and f of g is equal to id on y. Okay, so according to the definition of functor preserve composition, so f of g of f is equal to f of g of f is equal to f of g compose f of f according to the definition of functor, and f of id on x is equal to f id on f of x according to the definition of functor. It should be preserve a composition and it should be preserve identity map. Okay, so we have to prove functor preserve isomorphism. So let's say f of g of f is equal to f of g compose f of f and f of id on x is equal to id on f of x. So according to the definition of functor, it should be preserve identity. So it sent to functor send this morphism id on x to f of id on x, which is equal to id on f of x. Okay, and f of id on y is equal to id on f of y. Id on f of y according to the definition of functor. So we have to prove f of g of f is equal to f of id on x. Okay, means f of g, we have to prove f of g compose f of f is equal to id on x. We have to prove this first, id on f of x, and second, if we compose f of f compose f of g, it should be equal to id on f of y. Okay, if we prove these two, Then we can say F functor. F is a functor preserve isomorphism. Okay, isomorphism. So according to the definition of functor in previous page, functor preserve identity morphism f of id on x is equal to id on f of x. According to the definition, f of g of f is equal to f of id on x. So according to the definition of functor, f of g of f is equal to f of g compose f of f. And according to the definition of functor, it sent to this. So this should be equal. Okay. So if we wait a minute, means f of g compose f of g compose f is equal to f of g compose f of f by definition of functor, and f of id on x is equal to id on f of x according to the definition of functor. Okay, so id on x according to the given condition, id on x is equal to g of f. So functor send this to f of g compose f of f, and functor send this id on x to id on f of x, means f of g compose f, means g of f of g compose f is equal to id on f of x. Okay, according to this condition, this is these two morphisms are equal. So f of g of f is equal to id on x. So g of f send f to f of g compose f of f, and id on x send to id on f of x. This from f of x to f of x, and this morphism also from f of x to f of x. So both are equal. Now next condition is, according to given condition, f of g is equal to id on y. Okay, these two morphisms are equal because f is isomorphism. So according to the definition of functor, f of g, sorry, functor send this morphism f of f compose f of g, because f of f composed g is equal to this f of f composed f of g, and functor sent this id on y to identity of f of y. So they are equal according to the definition, because the morphisms are equal, so it should be equal. So functor preserves morphism.